The year is 1021 CE. In a darkened room in Cairo, a man sits perfectly still, a small hole pierced in the wall behind him. Sunlight streams through this tiny opening, projecting an inverted image of the world outside onto the opposite wall. Trees appear upside down. People walk on their heads. The sky touches the ground. This man is watching, measuring, thinking. He is solving a mystery that has puzzled humanity since we first opened our eyes. How do we see? How does light work? How can we trust what our eyes tell us? His name is Ibn al-Haytham, and in this moment, he is inventing the scientific method itself, 1,000 years before we credit it to Francis Bacon. He is laying the foundation for cameras, eyeglasses, telescopes, and every optical device you've ever used. But here's what's remarkable. You've probably never heard of him. Today, we're uncovering the lost legacy of Muslim scientists who revolutionized our world. Scholars whose discoveries we use every single day, yet whose names have been erased from our collective memory. This is the story of how Islamic civilization preserved ancient knowledge, advanced it beyond recognition, and gave birth to the modern world. This is about the forgotten minds who changed everything. If you're ready to discover the hidden architects of our modern world, hit that like button and subscribe, because this journey will transform how you see science, history, and the debt we all owe to these brilliant minds. To understand these scientists, we must first understand the world they created. The year is 762 CE. The Abbasid Caliph Al-Mansur is founding a new city on the banks of the Tigris River. This city will be called Baghdad, and it will become the intellectual center of the world, not for decades, but for centuries. At its heart will stand an institution that will change human history, Beit al-Hikmah, the House of Wisdom. Imagine the greatest library, research institute, and translation center ever conceived, all in one place. The House of Wisdom wasn't just a library where books gathered dust. It was alive with activity, controversy, and discovery. Scholars from across the known world, Muslims, Christians, Jews, Zoroastrians, pagans, gathered here, united by one thing, an insatiable hunger for knowledge. The Abbasid caliphs had a revolutionary idea. They sent envoys across the known world with a single mission: bring us knowledge. They traveled to Byzantium, Persia, India, and China, acquiring manuscripts in Greek, Sanskrit, Syriac, and Pahlavi. These texts contain the accumulated wisdom of ancient civilizations: Aristotle's philosophy, Ptolemy's astronomy, Euclid's geometry, Galen's medicine, Indian mathematics. But here's what made Islamic civilization unique. They didn't just preserve this knowledge. They didn't simply translate and store it. They questioned it, tested it, expanded it, and ultimately transformed it. They created something entirely new, a culture where evidence mattered more than authority, where experimentation trumped tradition, where a scholar's argument was judged by its logic, not by the scholar's religion or status. One caliph, Al-Mamun, was so passionate about knowledge that, according to legend, he dreamed of Aristotle, who told him, "Reason and revelation are compatible." Al-Mamun took this as a divine sign. He institutionalized the translation movement, personally funding scholars and paying them in gold the weight of the books they translated. Think about that. Knowledge was literally worth its weight in gold. This wasn't just about books. The House of Wisdom contained astronomical observatories, mathematical workshops, and experimental laboratories. Scientists here weren't just reading about the world. They were measuring it, testing it, and rewriting the rules. This is where our story truly begins, because this culture of inquiry produced minds that would illuminate the darkness of human ignorance. And the first of these minds belonged to a man who would revolutionize mathematics forever. His full name was Muhammad ibn Musa al-Khwarizmi, and every time you use the word algorithm, you're speaking his name. Every time you solve for X, you're using his invention. His impact on your life is so profound that you literally cannot escape it. Born around 780 CE in Khwarizm, in what is now Uzbekistan, Al-Khwarizmi came to Baghdad as a young man and joined the House of Wisdom. There, he looked at the mathematical traditions of Greece, India, and Babylon, and he saw something no one had seen before, a way to unify them all. The Greeks had geometry, beautiful, visual, but limited. The Indians had a revolutionary number system, including zero. The Babylonians had practical methods for solving problems. Al-Khwarizmi synthesized all of this into something completely new. In 820 CE, he wrote a book with a title that would echo through history. Al-Kitab al-Mukhtasar fi Hizb al-Jabr wal Kabbalah, the compendious book on calculation by completion and balancing. That word, Al-Jabr, means restoration or completion. We know it today as algebra. Before Al-Khwarizmi, if you wanted to solve a problem, you had to memorize hundreds of specific methods for specific situations. He showed that all these problems were actually variations of a few simple patterns. He created a universal language for problem solving. But here's what's truly revolutionary. He divorced mathematics from geometry. For the ancient Greeks, numbers were always tied to physical shapes and proportions. Al-Khwarizmi showed that mathematics could be purely abstract, purely logical. He showed that you could manipulate symbols according to rules, and these manipulations would reveal truth. He wrote, "What must I do to find the answer?" Then he systematically showed the steps, the algorithm, to reach that answer. This step-by-step logical process, that's why we call it an algorithm, from his name, Al-Khwarizmi. His second revolutionary contribution was introducing the Hindu-Arabic numeral system to the Islamic world and eventually to Europe. The numbers you're reading right now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, came to the West through his work. Imagine trying to do multiplication with Roman numerals. Multiply XXXIV by LXXVII in your head. Can't do it? That's why Al-Khwarizmi's numbers changed everything. Europeans couldn't even pronounce his name correctly, so they called him Algorithmus, and the methods he taught became known as algorithm. Eventually, any step-by-step procedure became an algorithm. Every app on your phone, every computer program ever written, every search engine query, all of these are algorithms, and they all trace back to this one man in 9th century Baghdad. Without Al-Khwarizmi, there would be no computer science, no cryptography, no engineering as we know it, no modern economy. He gave humanity the language to describe patterns, solve problems, and build the future. But mathematics wasn't the only science being revolutionized. While Al-Khwarizmi was creating algebra, another mind was looking upward at the stars and asking questions that would birth modern astronomy. His name was Muhammad ibn Jabir al-Battani, known in the West as Albatenius, and he did something extraordinary. He proved that the greatest astronomical minds of ancient Greece were wrong. Born in 858 CE in what is now Turkey, Al-Battani spent decades making precise astronomical observations. But unlike astronomers before him, who simply recorded what they saw, Al-Battani measured with unprecedented accuracy. He built advanced instruments, improved astrolabes, quadrants, and observational tools that allowed him to measure celestial positions to a precision never before achieved. For centuries, everyone accepted Ptolemy's measurements of the cosmos. Ptolemy, the great Greco-Roman astronomer, had calculated the length of the solar year, the precession of the equinoxes, and the movements of planets. His word was gospel. But Al-Battani discovered that Ptolemy was wrong. Through careful observation over many years, he calculated the solar year to be 365 days, 5 hours, 46 minutes, and 24 seconds. The modern measurement? 365 days, 5 hours, 48 minutes, and 46 seconds. He was off by just over 2 minutes, an astonishing achievement for observations made with the naked eye and medieval instruments. He didn't just correct Ptolemy. He fundamentally advanced astronomy. He discovered that the distance between Earth and the Sun varies throughout the year, which meant Earth's orbit isn't a perfect circle. He accurately calculated the precession of the equinoxes. He created precise tables showing the positions of the Sun, Moon, and planets that were used by navigators and astronomers for centuries. But here's what made Al-Battani truly revolutionary. He insisted that astronomy must be based on observation, not just theory. He spent night after night measuring, recording, checking, and rechecking. He understood that science advances through precision, through questioning even the most respected authorities, through trusting evidence over tradition. When Copernicus revolutionized astronomy in the 16th century with his heliocentric model, he cited Al-Battani dozens of times. When European navigators sailed across oceans in the age of exploration, they used tables based on Al-Battani's calculations. He built the foundation upon which modern astronomy stands. Every time we launch a satellite, predict an eclipse, or navigate by the stars, we're using principles refined by Al-Battani over 1,000 years ago. Yet ask a random person on the street who invented modern astronomy, and they'll say Galileo or Copernicus. They won't mention the Muslim astronomer who made their work possible. Now we return to that darkened room in Cairo, to the man watching light stream through a tiny hole. Abu Ali al-Hasan ibn al-Haytham, known in the West as Al-Haytham, is arguably the most important scientist you've never heard of. And I don't use that word lightly. Many historians of science believe he should be called the first true scientist, because he was the first person to consistently use what we now call the scientific method. Born in 965 CE in Basra, Iraq, Ibn al-Haytham was a polymath. He made groundbreaking contributions to mathematics, astronomy, physics, and philosophy. But his greatest achievement was in optics, and his greatest innovation was in how he pursued truth. For thousands of years, humans believed that vision worked by our eyes emitting rays that touched objects. This was what Plato taught, what Euclid believed, what everyone accepted. Ibn al-Haytham asked a simple question. If that's true, why can't we see in the dark? He then did something revolutionary. He didn't just philosophize, he experimented. He created that dark room, the camera obscura or dark chamber, and watched how light behaved. He saw that light travels in straight lines. He saw that light reflects and refracts according to mathematical laws. He saw that vision occurs when light from objects enters our eyes, not the other way around. But he went further. In his masterwork, Kitab al-Manazir, Book of Optics, completed around 1021 CE, he laid out a method that would define science itself. Observe a phenomenon, form a hypothesis about why it happens, test that hypothesis through experimentation, analyze the results mathematically, and only then draw conclusions. If your results don't match your hypothesis, change your hypothesis, not your results. Listen to his own words. The seeker after truth is not one who studies the writings of the ancients and follows his natural disposition to trust them, but rather one who suspects his faith in them and questions what he gathers from them. One who submits to argument and demonstration. Read that again. He's saying, don't trust authority, including mine. Trust evidence. Trust logic. Trust what you can demonstrate. This is the scientific method, stated clearly in 1021 CE. 6 centuries before Francis Bacon is usually credited with inventing it. Ibn al-Haytham's Book of Optics was translated into Latin in the 12th century and became one of the most influential scientific texts in history. Roger Bacon studied it. Johannes Kepler cited it when developing his laws of planetary motion. Galileo used principles from it when building his telescope. Descartes relied on it for his work on optics. The entire field of optics, which gave us eyeglasses, microscopes, telescopes, cameras, fiber optics, lasers, and every optical technology, traces directly back to this one book written by a Muslim scientist in 11th century Cairo. But Ibn al-Haytham gave us something even more valuable than optical laws. He gave us a way of thinking. He showed that truth isn't found in ancient texts or religious authorities or philosophical speculation alone. Truth is found through systematic inquiry, through testing, through being willing to admit when you're wrong. In the darkened room where Ibn al-Haytham conducted his experiments, he lit a candle that still burns today in every laboratory, every research institution, every place where humans pursue truth through evidence. That candle is the scientific method itself. Now we journey to Al-Andalus, Muslim Spain, to meet a man who revolutionized medicine and surgery so profoundly that his instruments and techniques are still used today, over 1,000 years later. Abu al-Qasim Caliph ibn al-Abbas al-Zahrawi, known in the West as Abulcasis, was born in 936 CE near Cordoba. In his time, surgery was considered a lowly profession, barely distinguished from butchery. Most physicians refused to perform operations. Al-Zahrawi transformed surgery into a precise, scientific discipline. His masterwork, Al-Tasrif, a 30-volume medical encyclopedia, contains the first comprehensive illustrated guide to surgical instruments and procedures. And when I say comprehensive, I mean revolutionary. He described and illustrated over 200 surgical instruments, many of which he invented himself. Al-Zahrawi invented the surgical use of catgut for internal stitches, the same material used in surgeries today. Because catgut is absorbed by the body, no second surgery is needed to remove stitches from internal organs. He figured this out in the 10th century. He performed the first successful cesarean section where both mother and child survived, documenting the procedure in detail. He described how to remove cataract from eyes. He created specialized surgical instruments for throat surgery, including an instrument remarkably similar to modern tonsillectomy devices. He invented surgical needles, forceps, scalpels, and retractors with designs so effective they're essentially unchanged in modern surgical kits. He pioneered the use of antiseptics, recognizing that infections following surgery were a major cause of death. He advocated for cleanliness and developed ointments that prevented infection, centuries before germ theory. But what made Al-Zahrawi truly revolutionary was his insistence that surgery required training, skill, and knowledge. He wrote detailed instructions for every procedure, including potential complications and how to handle them. He essentially created surgical training as a discipline. His work was translated into Latin and became the standard surgical text in European medical schools for over 500 years. Every surgeon trained in Europe from the 12th to the 17th century learned from Al-Zahrawi's book. When you watch a modern surgery, with its precise instruments, systematic procedures, and emphasis on cleanliness and skill, all of that traces back to Al-Zahrawi. Medieval Europe called him the father of surgery. Yet today, few medical students learn his name. But every time a surgeon makes an incision with a scalpel he designed, or uses forceps he invented, or stitches with catgut he pioneered, Al-Zahrawi's legacy lives on in every operating room on Earth. We could continue for hours. I haven't told you about Ibn Sina, Avicenna, whose medical encyclopedia was used as the standard medical textbook in Europe for 600 years, or Al-Biruni, who calculated Earth's circumference to remarkable accuracy and founded comparative anthropology, or Al-Jazari, who created automatic machines and programmable robots in the 12th century, or Fatima al-Fihri, who founded the world's first degree-granting university in 859 CE, or countless others whose contributions shaped our world. But here's the question we must confront. Why have these names been forgotten? Why do we learn about the scientific revolution as if science began in 16th century Europe, when these Muslim scientists were doing revolutionary work centuries earlier? The answer is complex and troubling. Part of it is linguistic. Many of their works were translated into Latin, and the translators took credit or changed the names. Part of it is cultural bias. For centuries, Western historians dismissed Islamic civilization's contributions as mere preservation of Greek knowledge, ignoring the revolutionary advances Muslim scientists made. Part of it is historical erasure. When the Mongols sacked Baghdad in 1258 CE, they destroyed the House of Wisdom and threw so many books into the Tigris River that witnesses said the water ran black with ink. Centuries of accumulated knowledge vanished. When the Reconquista ended Muslim rule in Spain, libraries were burned, manuscripts destroyed. Knowledge was lost, but the erasure continued even after the knowledge survived. Renaissance Europe, while building on Islamic science, often failed to credit its sources. The narrative became, we recovered ancient Greek wisdom and built upon it, conveniently erasing the 7 centuries when Islamic civilization not only preserved that wisdom, but transformed it beyond recognition. Today, this matters more than ever. We live in a world where cultures are increasingly polarized, where East and West, are portrayed as fundamentally different and opposed. But history tells a different story. History shows us that knowledge belongs to no single civilization, that brilliance has no religion or ethnicity. The human progress happens when cultures exchange ideas freely. These Muslim scientists weren't just Muslim scientists. They were human scientists advancing human knowledge. Al-Khwarizmi's algebra doesn't work differently for Christians or Jews. Ibn al-Haytham's optics don't refract light differently for different religions. Al-Zarawi's surgical instruments heal human bodies regardless of the patient's faith. Their legacy challenges us to remember that science is a collective human achievement built over millennia by minds from every corner of the world. Every time we use the number 0, we should remember it came through Islamic civilization from India. Every time we use algebra, we should remember Al-Khwarizmi. Every time we use a camera, we should remember Ibn al-Haytham. Every time we trust in the scientific method, we should remember the culture that refined and perfected it. These scientists believed that seeking knowledge was a sacred duty, that understanding creation was a way to understand the Creator, that truth was worth pursuing regardless of where it led them. They stood on the shoulders of those who came before them, Greek, Indian, Persian, Chinese, and they in turn provided shoulders for those who came after. The European scientists of the Renaissance, the Enlightenment, and today. The story of these forgotten Muslim scientists isn't just a story of the past. It's a story about what we choose to remember and what we choose to forget. It's a story about giving credit where credit is due. It's a story that should humble us, inspire us, and remind us that our debts to each other run deeper than we usually acknowledge. If you've made it this far, then you already know one thing. History is deeper, richer, and far more connected than we were ever taught. If you want more stories like this, stories that uncover the hidden geniuses, the forgotten civilizations, the breakthroughs that shaped our world, then don't leave without joining this journey. Hit that like button so this message spreads. Subscribe so you never miss the next chapter. And turn on notifications, because the next video will take you even deeper into the untold history of our world. This is your place for knowledge, truth, and the stories that deserve to be remembered. Until next time, keep learning, keep questioning, and keep seeking the truth.